Many students struggle with the maths required for GCSE Physics or Science. Let's see if we can break down using equations and make it simpler. The good news is that the government have announced that you will have equation sheets until at least 2027, so there's no need to learn any of the equations. Some equations you've been using since before your GCSEs, things like speed is distance over time, but some are going to seem new and quite complicated to you, like v squared minus u squared equals 2as, or delta E equals mc delta theta. Don't be afraid though. We're going to look at a simple way of choosing the correct equation, then we're going to look at how to simplify, rearrange and solve. Why not hit subscribe now, then you'll find all my videos on all the different equations and all the resources that go with them. A variable is a value that can change. For example, we have length, mass, temperature and time. Each variable has its own symbol. Little m is used for mass and little t is used for time. They aren't always that simple though. For example, momentum has the symbol p. We sometimes use the Greek alphabet for our symbols. For example, density has the Greek letter rho as its symbol, and temperature we like to use theta. We also sometimes use the Greek letter delta to represent change. For example, delta V would be a change in velocity. So whenever you see the Greek letter delta, think change. Right, let's jump in and have a look at an example question. An object accelerates with an acceleration of 3 meters per second squared and has a mass of 40 kilograms. What force makes this happen? Now, if you struggle with these things, then the first thing to do is read the question carefully and make a list of all the variables mentioned in the question. For example, the acceleration A is 3 meters per second squared. The mass, little m, is 40 kilograms. The force is mentioned, but we don't know what the force is. So let's put F equals question mark. Now I look at my equation sheet. I'm looking for an equation that has a capital F in, a big F for force. And I also want to see if it's got the other variables in. I'm going to use the AQA combined science data sheet here, but each exam board and each exam has its own. They're all very similar. As I look through the list, I can see there's several equations that have a capital F in. Here, for example, we've got F equals KE. For those who don't know, this is the equation for Hooke's law and springs. We can see we've got an F, but K, well, we don't have a K in our list of variables, and we don't have an E in our list of variables, so it can't be that equation. So let's keep looking on the data sheet, and sure enough, we find F equals MA. We've got an F, we've got an M, we've got an A, so this equation is the one to use. Putting the numbers in, I get F equals MA, which equals 40 times 3, which equals 120 newtons. Don't worry if you haven't seen this equation before, I've just used it as an example. The same method will apply for picking any other equation off the sheet. Now let's look at an example with 4 variables in it. What's the specific heat capacity of water if it takes 84,000 joules of energy to heat 2 kilograms of water by 10 degrees? First thing we're going to do is make a list of the variables. The question asks, what is the specific heat capacity? Well, that's clearly the variable we're trying to find. Specific heat capacity has the symbol C, so I'm going to write down C equals question mark. It tells us the energy is 84,000 joules, so I can write down capital E equals 84,000 joules. It tells us the mass is 2 kilograms, so I can write down little m equals 2 kilograms. It also tells us the change in temperature is 10 degrees. The symbol for temperature is theta, and if you want to be pedantic about it, the symbol for change in temperature is delta theta. But for today, let's allow either of those. So theta is 10 degrees. We are now going to look through our equation list and find an equation with C, the specific heat capacity in it. Let's have a look at this one. Delta E equals MC delta theta. Well, it's got the C in it, but have we got all the other variables in our list? E, yes, we've got E, the change in energy, delta E. M, yes, we've got M, we've got the 2 kilograms mass. And theta, or delta theta, the change in temperature, yes, we've got that. So that is a good equation to use. Here are the 4 steps I'd like you to follow. Firstly, we substitute the numbers in correctly, the correct values for each variable. Secondly, we simplify the numbers we've got. If there's any little calculations we can do to make it look prettier, then let's do that. Thirdly, we're going to need to rearrange our equation. Fourthly, and finally, we just then type the numbers into the calculator and get our answer. Before I talk you through these 4 steps, can I point you in the direction of my website, where there's lots of free resources, including questions and answers, to go with this video and every other video that I make. I also love it if you could like and subscribe and even comment. That helps me to keep making free resources. As well as all the free resources, I do offer one-to-one tuition as well as small group lessons. So if you're interested, there's more information on the website. Right, back to the question. First, let's substitute the numbers in. Because we've made a list of our variables, this is quite straightforward. 84,000 for the energy equals 2 for the mass times C, our unknown, times 10 for our change in temperature. Secondly, we simplify. Well, there's not a lot we can do with 84,000, but we can do something with 2 times 10. We can make that 20. So we get 84,000 equals 20C. Hopefully this is not unlike the algebra you've seen in maths, where there's one unknown and a couple of numbers. Let's see if we can rearrange it to get C on its own. So we get 84,000 divided by 20 equals C. It's divided by 20 on that side of the equation because it was times by 20 on the other side of the equation. So times becomes divide. Likewise, divide becomes times, plus becomes minus, and minus becomes plus. The last stage is to do the calculation. 84,000 divided by 20 gives us 4,200, and the correct units are joules per kilogram degrees C. So when the maths gets complicated, what I want you to do is list your variables, look at the data sheet for the correct equation, substitute the variables into the correct place, simplify any little simple calculations in there that you can, rearrange to get the unknown quantity on its own, and then stick the numbers in your calculator to get the answer. Now, of course, once you get better at it, you won't have to go through all this and make a list of the variables and everything else. But if you are struggling with your maths, this should help you not make mistakes and take you through it step by step. It may be that you've been taught another way of solving these calculation problems, and by no means am I saying mine's the best and only way. You may also be able to simplify my method quite a bit as you grow in confidence and get better at doing it. You may also get a calculation question for more marks, which requires more than one equation to be used, quite often 2 for a 6 marker. I will cover how to tackle questions like that in another video. But for now, why not watch this?